Good evening, and welcome back to Vegas October 1 Sounds. I've been doing a little work on my computer the last couple days. It's still not done, but good enough to get back to producing a couple of videos. Tonight, we're going to continue the saga into the investigation of that one sonic crack that occurred out near the church area from a Manny S video. And I looked around and examined more than 50 videos in search of all the attributes of Volley 7, which is the volley that we're talking about. And I came up with this officer cam recording from batch 11, number 85, as representing a pretty significant share of the middle portion of the volley. And we're going to look at this because it has recorded several hits. And now if you look at the map, when Volley 7 was recorded, this officer is somewhere in this general vicinity there, which, as you can see, occurs pretty respectably close to some shots. Now I don't know that the deaths there were a result of Volley 7, but it's close to where the action happened and some dead bodies, so it would be fruitful to go look at the other videos, like from the rooftop cam, to see if there was something that could be spotted during Volley 7, and I'll eventually get to that. But anyway, so this is the video that we're going to be looking at this evening. I'm going to try and make this a short video so that we don't get bogged down in all the stuff. And yes, contrary to what Dub and Thumper think, real research does take time, and it takes a lot of analysis. Generally with acoustics, there's no simple answers. So anyway, without further ado, let's go ahead and look at the portion of this that is of interest in Sonic Visualizer. On the top graph here, we have once again the powers, the dB squared, which shows that there was some pretty significant energy expelled right in the middle of this volley and shortly thereafter. And this middle portion is what I commonly refer to as the talking guns phenomena, where you go along with this volley. If you look at the second pane, which is the log frequency plot, you go along with a bunch of muzzle blast sounds, and then all of a sudden in the middle of the volley you get these monster cracks, supersonic cracks for about 11 to 18 shots, and it dies down and it goes along back to the muzzle only. And then of course towards the end here is the thing that we've really been looking for. But by looking at this and observing back at the Manny S tape that there were no supersonic cracks except for the one, we can start to come up with some answers. And the answers is that this is the closest recording I could find that recorded hits. That is, the bullets were hitting something in the general vicinity of the officer who recorded this, not real far away. Pardon me. And so if we expand this out, always keeping in mind that these are muzzle blasts down here with very few supersonic cracks, and then we get these massive energy dumps. And as you can see by the brightness, they aren't just some common run-of-the-mill supersonic cracks. In fact, that they have this tremendous amount of energy for, in this case, 1, 2, 3, 4, 5, 6, 7, 8, at least 9, maybe 10, and I'm not sure what these little things are. But up here on the power thing, again, we can 1, 2, 3, 4, 5, 6, 7, 8, at least 10. And let me double check that. 11, 12, probably for 12 shots out of the, let's see if I count them. They're somewhere, let's see, 1, 2, 3, 4, oh golly, 5, 6, 7, maybe 8, 9, 10, 11, 12, 13, 14, 15, 16. So out of the 16, maybe 18, 16 to 18 shots there, 2, 3, 4. There were 10 or 11 hits, and that's a pretty high ratio of hits. What they hit, I cannot say at this time because my analysis has not gone far enough to distinguish between soft body hits, hard body hits, hits to the astroturf. I don't know if there was any up there. Hit to a building, hit to a tin, and all that. What we can say is that these are extremely loud occurrences. Now, if we look at this first one here in great detail, and first off, let's start with a frequency preferred scale on this, in fact on both of them. Then we can see that there's some high frequency sound and that there's some low frequency sound, and that the low frequency sound is down in the 381 hertz and below, and that the high frequency sound is somewhere up on the 25 to 3500 hertz. So as you recall, the lower frequency range is precisely that of a muzzle blast, but the width of this is way too wide to be a muzzle blast. This is on the order of 30 milliseconds, and a muzzle blast only occurs for, I would say, at most 3 milliseconds. So this is 10 times wider than a muzzle blast. And so you immediately start to suspect that there's something going on here that's unusual. Now, if we were to play this, let's just go ahead and play the entire volley, so you can get a feel for the difference in the sounds. Oops, I got some things in there playing that I don't need to. So forget what you just heard. Let's see if I got them out. Alright, let's play it once more, since I got the little beeping sound from my time marks out. Okay, so on this scale, the volley starts out playing, some muzzle blasts, not tremendously loud, not tremendously soft, no supersonic cracks, and then the muzzle blasts get louder for, quite a few. Then they get a little bit softer, and then all of a sudden you get these massive supersonic crack sounds along with some big thuds, people really screaming, and that goes on for a bit, and then it gets softer, and then you get these electronic sounds, and those electronic sounds are the 20-second interval beeps that the cop cam has, where the camera during the recording, and I forget exactly why, is that either the clock's not on or I forget why. I should know, but I don't. But anyway, every 20 seconds or 2 minutes, the cameras make a beep, and then that's recorded. Not the cameras, but the other part of the radio. Excuse me, the radio. That's what it is. The radio makes a beep, and then that's recorded on the camera. So, if you've listened to any of these things, you know how loud the that sound is. But by comparison, these other sounds over here, which I'm calling hits, are substantially louder. So we know that these sounds, for real, are quite a bit louder than those over there, and way much louder than these over there, maybe as much as 10 times. So, and if you've listened to enough of these, and oh, by the way, yes, there are supersonic cracks in this volley, in this video. To answer Dub's question is, has anybody heard any supersonic cracks? And show me one damn video that shows any supersonic cracks. Here it is, fella. Not only are there supersonic cracks, but there's hits. And if we were to let's say go to any other time frame on this. Let's look ahead to volley 9, see what it did. I'm not sure which one this records. Let's go back over to my timetable. Let's see, we got volley 5 at 147, so let's go to 147. No, don't see much there. I mean, you can see the, oh yeah, there we go. There's part of volley 5. And yeah, it's not real bright, but you can see some of them. These top things are the supersonic cracks. The middle things over here are the muzzle blasts. Very faint though. Let's try and get a better one. Let's take volley 10 at 529. 529. Yeah, this one has a lot of supersonic cracks in it. This is volley 10, or some portion of it. And you can see here very, very clearly that, and we're on the 1000 scale, so if we put it on 512, they'll come in much better. Here we go, that these lower frequency things are the muzzle blasts, and then in between or slightly ahead or behind those are the supersonic cracks. So in this case, the volley 10 has supersonic cracks for just about every muzzle blast. So once again, this is pretty typical that nearly every volley records some number of supersonic cracks depending upon your location in the venue. But back to volley 7, since we're really more interested in that. Okay. Here we are, volley 7. So I'm talking about these hits. Now, if these were the hit, if these are indeed hits, and we're going to look at this in a little bit more detail now, get down into the nitty-gritty of it. And to do that, we have to adjust our windowing size down to 128, because the smaller the windowing size, the greater the accuracy of timing of when an event occurred, but the less the accuracy and frequency. But if we jump down to a windowing size of 128, then what we can see is this 30 millisecond or more longer low frequency sound, and right in the middle is a high frequency supersonic crack. So in this case, the sound of the hit occurred a few milliseconds before the sound of the supersonic crack was received. And to do that, you have to be on the upstream side of the bullet path. That is, you have to be closer to the shooter than where the bullet hit. But you still nevertheless have to be pretty darn close to where the bullet strikes were happening. Now, if we want us to look at a very precise definition of the wave, then what we see here is pretty interesting, because the wave, there we go, the amplitude waveform is just massively large and huge, and so loud in fact that these flat portions on the top and the bottom have exceeded the capacity of the camera to record it, and that's what's called clipping. And because of that clipping, there's substantial amounts of information being lost. But the width, by comparison, the width of the supersonic crack, which is right there, we'll look at it on a very small scale, a very fine scale, and you'll see that, you know, pick anything that's one cycle, and we'll see that the width of that would be right around 385 microseconds, which is, you know, pretty good for a supersonic crack at, you know, with this low resolution thing. And the if you could determine where it ends, we're actually looking at the primary signal, the first wave of that thing is on the order of 8 milliseconds. So the first wave of that hit came in at milliseconds, and then it oscillated around, extending out to about 20 some milliseconds, until it just died off enough that it was subsumed by the background noise. So this is one typical signature of a hit. In this case, this one precedes the arrival of the supersonic crack. In many cases, they're so close. In fact, we probably have one on here, so close that they're on top of one another. That one, I can't quite tell where the supersonic crack comes there. Let's see if we put that part back up. Yeah, it looks like the supersonic crack actually came right at the, well, hard to say exactly where, but it came on either the rise or the fall of the hit wave, and because it was such lower amplitude, it's not even readily apparent. It's probably that little trivial bump right there on the downfall side. Let's take a look at the next one. So in this case, it's really hard to tell there too. Now here's one where it comes in at the lead in. This one, it's pretty clear because of the way that this comes up and down, that the supersonic crack occurred right at the lead of the hit, which means that the sound from the hit and the sound from the supersonic crack arrived at the recording device at approximately the same time. And that's pretty typical on many other recordings where there's hits recorded. Now this one did not have much clipping in it. These, wow, they're all over the place. In this case, what you have is something hitting an object which is stiffer because it causes more oscillations. Notice how these waves are going up and down quite a bit compared to, pick one of these back here where it goes up and down once and then tapers off real quick. You have one wide one followed by some oscillations. That's called critical dampening. And over here, it just oscillates for a long time. That's more indicative of a hard, stiff, metallic type thing than of a soft body which absorbs the energy quickly. So I would say that, for example, these two, this one on the right and this one on the left, hit different types of object. This one being softer in nature than this one was being harder. And so this one could have been a hit to a metalish type object. This one could have been a hit to wood, person, or turf, astroturf, and I'm not sure which at the moment. And that one was right there where, that one's definitely to a soft target of some type, wood or a body. Alright, so what we have learned here, and then over here the cop cam sound, you see they're completely different looking. They're almost square in nature. They look like, I call them the field goals, because they have a spike at the front, spike at the end, and in the middle they're relatively flat. But they have this very well defined frequency band that they're in. In fact, if we go back to the frequency preferred accuracy, you'll see that there's two bands there. One's at 3617 and the other at 2542. So that's an electronically generated signature right there. Nothing, in nature has such a well-defined and narrow band that we commonly hear. Alright, so back down to our 1/28 scale. So we've identified that in Volley 7, located out in the middle of the venue, there were probably 10 to 12 bullets that hit things, some soft and some hard. What does that mean overall? Well, it means that from prior videos, we've identified that the lag, the time of arrival between the muzzle blast, between the supersonic crack and the muzzle blast, was the smallest the further away you are from the Oasis apartments. And that corresponds on this graph being closer to your why did that start up when I wanted to do? Alright, let's see here. So I was clicking on the wrong thing, that's why. Now we got the pencil. Let's put it over here so I'm not confusing it with the recording. Alright, here we go. I was clicking over there. So, for this one, we identified in the Talking Guns video that they occur during this range right here, that those shots occurred right during this lag part of the graph. And we see that as they grew further away from us, the lag grew smaller. And then the one that we've constantly been talking about in the Manny tape is here, and it was a little bit smaller, therefore it was a further distance away. So if we go back to, oops, once again I wanted to click the wrong one, back to our graph over here on the Vegas shooting map, then if the volleys were here, then the single shot of interest that we've been trying to track down was most likely either above these or slightly north. So we've identified the possible paths for the one round that produced a supersonic crack on the Manny S video, and we've also identified where the bullets potentially hit for those 10 or 11 or 12 shots. Now that still leaves 80 some shots to go, and I'll eventually get to them, but I thought it's important to tell you and bring to your attention where the research is currently at, what it means, how I'm slowly but surely honing in on where the bullets are, and I'll eventually come up with video, if it exists, for that time frame showing what was happening in that region of the venue at that time. And then we can start correlating the events in the video with the events in the audio to come up with a more realistic picture. So, what else do I have to tell you about this? Well, let's erase that. Think about it a second. And remember, we're looking at you know, when you click on these maps, it's really hard to get them to highlight that line. There we go, that line. We're looking at that one for release batch 11, video cam number 85, if you want to go and listen to it for yourself. Okay. Alright. We covered that. And yes, there's plenty of supersonic cracks in that video. And I don't know why anybody would ask where the supersonic cracks if they've listened to any of these, because they're all over the place. Anyway, enough of that. Okay. So I think that's about it for this topic for this evening. I've also, you know, pretty well located the shots on the cam that Volley 7 laid down some bullets on the area where the cops were on the boulevard in Mandalay Bay, and those occurred a little bit earlier in the volley. And the ultimate goal here is to outline the cone of silence for every bullet that hit prior to going to the east side of the venue, so that we can predict where the supersonic cracks will be heard and where they won't. Because if you're to the upstream side of a bullet strike, that is, you're recording prior to when the bullet strikes, and then you're going to record the supersonic crack if there's enough dynamic range on the recorder over the background noise. But when you're downstream, after the bullet hits, the supersonic crack sounds stop being generated, and therefore if you're in a certain region downstream from the bullet, you're not going to record supersonic cracks. And that's what I in previous videos have called the cone of silence. And that's one of the predominant reasons that the recording out at the church did not record many supersonic cracks. In particular, these 12 things that I just showed you that were likely hits in that region would not have produced a field of sound for those bullets on the supersonic crack side, and therefore that would leave simply the muzzle blast to be recorded out of the church. So there we go. So we'll catch you in the next one.